In 10.2, we're going to continue on with some other trigonometric identities, in particular what we call the sum and difference identities. So if you look inside this box, and we're looking at cosine of a plus b, so a plus b are just some angles. So when you're adding angles and you're taking the cosine of it, you could use this formula that says it's going to be the cosine of a, cosine of b, the plus turns to minus, sine a, sine b. So something I'd like to remind you of right now is that if you have an addition or a subtraction inside the argument of the function, in this case the function is the cosine function, you cannot simply split it up into cosine of a plus cosine of b. That is not true. So with addition or subtraction inside the argument, you can't split it up that way. The only way that you can split it up is by using one of these formulas. So if you're taking a subtraction of angles, so cosine of a minus b, it's going to be cosine cosine, the minus turns to plus, sine sine. So cosine of a, cosine of b, plus sine a, sine b. So you would just follow the formulas, not necessary to memorize them, just have them handy so that you can refer to them when you're doing your exercises. Now, whenever we're adding or subtracting with the sine function, there's a little bit of a different pattern, but they all have patterns. So if it's addition with sine, it's going to be sine cosine plus cosine sine. So the addition stays the same. So sine of a cosine b plus cosine a sine b. Now if it's subtraction, order is going to remain the same. Instead of a minus, instead of a plus as in the formula above, it's just going to be a minus. So it's going to be sine a cosine b minus cosine a sine b. Tangent, a plus b tangent, a minus b. It's a little bit more complicated. And the reason why the formula is this complicated fraction is just because tangent is a fraction. It is sine over cosine. So you're going to have this very complicated formula that you don't have to memorize. Just remember that addition is going to be tangent A plus tangent B, and then in the denominator it's going to be a 1 minus tan A tan B. So if you're subtracting with tangent, it's going to be minus on the top, plus on the bottom. So what is the point of all of this? Well, the point is, if you're not using a calculator and you want to find the exact value for a degree or a radian that you don't know, like in example 1a, if I wanted to find cosine of 75 degrees, that's not a known value that I have, say, on my unit circle. However, if I could break 75 up into two angles that I do know, and then when we're dealing with degrees, we're really looking at 30, 45, 60, 90, and so on. We're looking at those degrees that we're familiar with. So one way I could break up 75, and you can either use addition or subtraction, is by saying, oh, okay, well, that's the same as saying 30 degrees plus 45 degrees. So cosine of 75 degrees, I could write that as cosine of 30 degrees plus 45 degrees. And then I can use that addition formula that it's going to be cosine sine, but the plus goes to minus. So it's going to be cosine of our first angle, which in this case, in the formula, A would be the 30 degrees and B would be the 45. So it's going to be cosine of 30 degrees, cosine of 45 degrees, plus goes to minus, and then you do sine 35, or 30, sorry, sine 45. And those values I know. I know that cosine of 30 is, so that'd be the same as pi over 6, which is square root 3 over 2. Cosine of 45 is square root 2 over 2. Minus sine of 30, half. Sine of 45 is square root 2 over 2. This becomes the square root of 6 over 4 minus the square root of 2 over 4. And then the final step would be combining these two fractions to get the square root of 6 minus the square root of 2 over 4. And that's as far as I can go without a calculator. Let's try this again, but this time we're going to look at radians. And oftentimes you'll have fractions here. That may be a little bit more difficult to see how you're going to break it up. So the idea is, and think about your unit circle, we don't know values where the denominator is 12. We know pi over 6, pi over 4, pi over 3, pi over 2. So if the denominator is 2, 3, 4, 6, we know what the value is. So the idea is to break up the 5 pi over 12 into two fractions, either addition or subtraction, where you could reduce it so that instead of a 12 in the denominator, you get a 2, 4, 3, 6, something like that. So think about how you would divide 12. If I divide 12 by, say, 3, I end up with a 4. So one way I could break up the 5 pi is by 4 pi plus 1 pi. But then the 1 pi over 12, I can't do anything with that. Maybe I could do 3. So if I took 3 pi over 12 plus 2 pi over 12, the 3 plus 2 pi would give me my 5 pi. But notice that 3 over 12 will reduce to pi over 4. 2 over 12 will reduce to pi over 6. And I know sine of pi over 4, and I know sine of pi over 6. And cosine as well. This would reduce to pi over 4 plus pi over 6. And now this is not the only way to break up 5 pi over 12. You could have chosen something else. You could have chosen something with a subtraction. This is just what I saw first. This becomes sine of pi over 4 plus pi over 6. And then using that addition formula, it's going to be sine cosine plus cosine sine. So sine of pi over 4 cosine of pi over 6 plus cosine of pi over 4 sine of pi over 6. Don't know if you can hear that crazy rooster outside my window. And then you're going to see these same values show up over and over again when you're using the addition or the subtraction formula for sine, cosine, and tangent. So sine of pi over 4 is square root 2 over 2, and that makes sense because we're breaking this up into values that we know on the unit circle, which are typically square root 3 over 2, square root 2 over 2, half, and so on. Cosine of pi over 6, that's going to be square root 3 over 2 plus cosine of pi over 4, square root 2 over 2. Sine of pi over 6 is 1/2. So very similar to the prior. We get square root of 6 over 4, but this time it's a plus square root of 2 over 4. And that brings us to the square root of 6 plus the square root of 2 over 4. Again, that's as far as I can go without a calculator, which is the whole point of this, to be able to evaluate trig functions without a calculator. Sometimes you'll have something expanded out and you want to use a sum or difference formula to bring it back in. So all of these identities, I call them formulas, but all of these identities have an equal sign. So you could either work from the right side to the left or the left to the right. So you can either expand it out like we did in the first two examples so that we can evaluate, or you could bring it in. When I look at C, I have 7 pi over 8 and pi over 8. I don't know any of the trig values when the denominator is 8. So I think that maybe I should combine this, because notice that if I do a subtraction of 7 pi over 8 and pi over 8, I'll get 6 pi over 8. And when that's reduced, I'll get 3 pi over 4. So what I'm noticing here is that this is cosine, cosine, plus sine, sine. Looking at the formula, cosine, cosine, plus sine, sine, that takes the form of cosine of A minus B. Let's go back up to our formulas. So this is cosine, cosine, plus sine, sine. So in that case, I can actually bring it together where my A is going to be the 7 pi over 8 and my B is my pi over 8, which is exactly what I needed. So again, this would be my A and my B. This becomes cosine of A, 7 pi over 8, minus B, which is pi over 8. And then it's just a matter of subtracting those fractions to get 6 pi over 8 and reducing by 2 to get cosine of 3 pi over 4. And I know what cosine of 3 pi over 4 is. Here we're in quadrant 2, and it's going to be negative square root 2 over 2. So again, you can use those identities to expand out or bring together. This next example is fairly long, and it's going to be using the identity of adding angles or the addition or sum formula. In example 2, suppose that A and B are angles in standard position, so their initial side is on the positive x-axis. Use the given information to find sine of A plus B, and then find the quadrant in which angle A and B lies. So we have some information here. We know that angle A is between pi over 2 and pi, so that would be quadrant 2. We know that angle B is between pi and 3 pi over 2, so that would be quadrant 3. So we might think that, okay, well, when we add A plus B, won't we be in quadrant 4? Not necessarily. If A is closer to pi and B is closer to 3 pi over 2, we could end up in quadrant 1. So we really don't know. So let's do the first part. Let's do the sine of A plus B, because I do know what sine of A is, and I know what cosine of B is. Let's see how this plays out when we use our sum formula for sine. So remember, it's going to be sine, cosine, plus cosine, sine. So it's going to be sine of A, cosine of B, plus cosine of A, sine of B. I know what sine of A is. It's given to me. It's 4/5. And I know what cosine of B is. That's actually negative 5 over 13. I don't have cosine of A, and I don't have sine of B. So let's just simplify this. Notice that the 5's would cancel. And this would be a negative 4 over 13 plus cosine of A, sine of B. All right. Now I'm stuck. However, I have sine of A. So to find cosine of A, what I could do is use the Pythagorean formula. Remember that sine squared plus cosine squared is equal to 1, and I know that sine of A is 4/5. So 4/5 squared plus cosine squared of A is equal to 1, which means cosine squared of A is equal to 1 minus 16 over 25. So 25 minus 13 is 9. I get 9 over 25, square root both sides. We get cosine of A is going to be plus or minus. And then the square root of 9 over 25 is just going to be 3/5. And since A is in quadrant 2, I know that cosine of A has to be negative. I would be choosing the negative 3/5. So now I could put that into my formula, but let's go ahead and do the same process. Let's find sine of B. Again, I'm going to use sine squared plus cosine squared is equal to 1. So sine squared of B plus cosine squared of B. So cosine of B was negative 5 over 13. And I'm going to be squaring that. I know that that's equal to 1, which gives me sine squared B is equal to 1 minus 25 over 13 squared, 169. Sine squared of B is equal to 169 minus 25 is 144 over 169. If I square root both sides, don't forget the plus minus, square root of 144 over 169 should be 12 over 13. Oops, said 12, wrote 13. Why? Okay, so B is between pi and 3 pi over 2. It's in quadrant 3, and sine is negative in quadrant 3. So for my sine of B, I would choose the negative. And now I have cosine of A and sine of B. I can go back to what we were doing before, the negative 4 over 13 plus cosine A sine B. That is now negative 4 over 13 plus cosine of A is negative 3 over 5. Sine of B is negative 12 over 13. All right, so that is what, 36? Oops. I forgot my negative 4 over 13 plus 36 over 65. Okay, so in my calculator, I get that is 16 over 65. Okay, that answers the first part of the question. What is sine of A? Let me rewrite this. What is sine of A plus B equal to? And we got 16 over 65. Okay. The second part was, what quadrant is A plus B in? Well, what I could do is look at the negative and the positive of sine and cosine. So sine is, and our answer was a positive 16 over 65. So sine of A plus B is positive. So that means that A plus B must be in quadrant 1 and 2. If I knew whether cosine of A plus B was negative or positive, then I can determine if we're in quadrant 1 or quadrant 2. So I'm also going to compute cosine of A plus B. And then the cosine formula is cosine, cosine. The plus goes to minus, sine, sine. So cosine of A let me just rewrite this. Cosine A, cosine B minus sine A, sine B. And then we could put in our values. Our cosine of A was negative 3/5. Cosine of B is negative 5/13 minus sine of A is 4/5. Sine of B is negative 12/13. And you know, I honestly don't even have to figure out what this is. Look at all those negatives. The minus turns to plus, minus a negative turns to plus. So this is actually going to be a positive. And I didn't even figure out what the value was. So if cosine of A plus B turns out to be positive, and sine of A plus B is positive, then that tells me that this is in quadrant 1. So we're in quadrant 1. And you can compute that long fraction thing if you choose. But again, remember, I'm lazy. The next thing we're going to do is what we did in our last section. We're going to do some verifications or some proofs. So just remember that when you're verifying, you work from one side to the other. You don't write down both sides. You don't have that equal in there because that's what you're trying to show. Okay. So I am going to choose to start on the left-hand side with cosine of 2x because that's actually what's bothering me. So far, we haven't had a verification where the angle was a multiple of something like a 2x or a 4x. And what I'm going to do is I'm going to split the 2x up into cosine of x plus x. And that will help me get rid of the 2x because then I can expand it using that identity that it's cosine cosine minus sine sine. So think of this as your A being x and your B also as x. This is cosine of x plus goes to minus sine of x, sine of x. I get cosine squared x minus sine squared x. So I need 1 minus 2 sine squared. So I know I have to keep that sine squared. That tells me that I should be getting rid of the cosine squared because it's not in my final right-hand side. And I know that cosine squared, maybe I could use the identity that sine squared x plus cosine squared x is equal to 1. So if I can solve and get the cosine by itself by subtracting the sine squared, this becomes cosine squared x equal to 1 minus sine squared x. So you have to be able to understand your identities and be able to manipulate them. So now that I have the cosine squared x equaling to 1 minus sine squared, I can go ahead and replace the cosine squared with 1 minus sine squared. And then I still have the minus sine squared. And I'm where I want to be because minus sine squared is minus 2 sine squared x. And we're done. Cosine of 2x, I've shown that it's equal to 1 minus 2 sine squared. Last exercise in this lecture is another verification or proof. I have a fraction on the left and I have an addition on the right. So I can either go right to left But what's bothering me here is that sine of A plus B. It seems to me that it's going to be difficult for me to start on the right-hand side and try to get a sine of A plus B. It seems easier for me to start on the left-hand side where I have sine of A plus B over cosine A cosine B. And again, I don't know how this is going to turn out, but what's irritating me is that A plus B in the numerator. And I know I can get rid of that by using the addition or sum formula for sine. So I'm going to start on the left-hand side. Again, you have to write this down, where you're starting from. So work from one side to the other. I want to get rid of that A plus B, so I'm going to use the addition formula or the sum formula for sine. So that's going to be sine cosine plus cosine sine. Sine of A cosine of B plus cosine A sine B. So again, I really don't know, and this is the honest truth. I don't know what this is going to look like. I just know that I had to get rid of the A plus B because it's not on the right-hand side. So I know I have to get rid of it, and it bugs me, and I'm in the section where we're using these sum and difference formulas. So what happens when you're working from a fraction to breaking it up into either addition or subtraction is this is a common thing that comes up where you're going to have an addition or a subtraction in the numerator, and then you have your term in the denominator. But what that allows you to do when you create the addition and subtraction in the numerator, it allows you to break your expression up into two fractions. So our common denominator is cosine A cosine B. And I can break this up into sine of A, cosine of B, over cosine A, cosine B. And you wouldn't skip any of this stuff, even though it may be obvious to you how, once you split it up, how it will reduce. So you may think that, oh, I can skip this step, but you actually can't, because remember, you're not solving anything. You're verifying. And when we verify, every step has to be shown because that's evidence that our identity or our equation is true. So this is going to be plus cosine of A sine B over cosine A cosine B. So now that I've split this up into two pieces with addition, which was part of my goal, I can then look at each piece and see if I can simplify it in some way. And I could see in my first fraction that the cosine of B will cancel top and bottom. And in the second, it would be the cosine of A. So you could see that once cosine B is gone, cosine A is gone. Sine of A over cosine A would be tangent of A. Plus tangent of B for the sine B over cosine B. And that's what I wanted. So I'm done. And that's it for this section.